Hello and welcome. In the previous lecture, we derived three formulas for ground to ground projectile, right? And the three formulas were for the time t. Now this time t is the time the projectile takes to reach the ground again. It starts from a ground. It's a ground to ground projectile. That means the projectile starts from one level, reaches at the same level. So what is the time it required to reach the ground again? It leaves the ground, reaches here. The time required is given by this, right? The range, this is the maximum horizontal displacement of the projectile. This range is given by this formula. And the maximum height attained by the projectile is given by this formula. Now this is all these formulas can be applied only in case of ground to ground projectile. There is a reason for that. What is the reason? See, in ground to ground projectile, the initial vertical velocity, you can see here, u is the velocity, the vertical component of it is u sine theta, because theta is the elevation angle. So u sine theta is the initial vertical velocity or initial vertical component of the velocity, right? So if it is u sine theta, when it reaches the ground at the same level, right, then it will come down at a velocity of minus u sine theta, right? And based on this assumption, we have derived this. It means these formulas are applicable only and only to ground projectile. Now this point I should have stated or emphasized in the previous lecture, which I didn't do, but I do it now. Remember this, right? Okay, now there is one more formula that is we need to derive. That formula will be like, suppose the projectile has come over here, right? Which means the projectile, let's say, has traveled horizontally a distance x, right? And so it comes here, it has that means it has moved horizontally by x and it has moved up by y, right? So what is the relationship between y and x? That is another formula. That's what we are going to derive. Okay, now first thing, right? So we are deriving an expression which is y as function of x, right? That's an expression which we are going to derive. Now let's see that first thing. You know that what is x? X is the horizontal displacement. Now this velocity vector is shown as u. I mean, did I say v initially? That was wrong. It is u, right? Initial. So its horizontal component is going to be u cos theta, right? U cos theta, and horizontal component of velocity will be constant in the projectile. So the displacement x is given by u cos theta into time, right? So let's say time is t. So that time is t means the projectile during that time has moved from here to here, which means it has displaced horizontally itself by x and its vertical displacement is y. So essentially we are saying x is equal to u cos theta, that's a horizontal component of initial velocity. So it is u cos theta into t. T is the time which projectile takes to reach from here to some point here, right? Okay. Now it means from this we can say t is given by x divided by u cos theta. There is a reason why we found out t in this fashion. Okay. Now let's consider vertical displacement y, right? So you see that this projectile is displaced by y. That means consider a vertical motion. Let's separate vertical motion. So this is initial vertical component of velocity, which is u sine theta, right? Initial vertical component of velocity u sine theta, and it reaches somewhere here. Okay, so here this is y. This is y, so I am taking it here. So I am considering a rectilinear motion, which we can do in case of projectiles. We can separate horizontal and vertical motion. So we are considering this. So we can now say that initial vertical component is u sine theta. It is moving, it is displaced by y. Okay, so now we will because we want to relate y and x, right? We want to relate y and x. I'm going to use the relationship kinematic equation for a rectilinear motion. S is equal to ut plus half at square. We are considering vertical displacement. S here is nothing but vertical displacement, which is y. U initial velocity, but we should take initial vertical velocity is u sine theta, right? U sine theta. And t, we can take this because t is given as x by u cos theta. We can write this as x by u cos theta. Now here you can see half at square. What is a? A is acceleration. Now see, this is a projectile and a projectile is pulled by gravity. So acceleration of this projectile is g downwards. Okay, as soon as it is in the air, the projectile is accelerated downwards, right? And so downward we take negative with negative sign, because u sine theta upward we have taken as positive. So a will be replacing it by minus g. So this is minus gt square by 2. But I can see we can place t as x by u cos theta. So this is t square. So it is x by u cos theta whole square, right? And this is 2. Okay. Now this can be simplified. We can say this u gets cancelled. I can write this. We can write this as x tan theta minus, here you can say gx square upon 2u square cos square theta. 2u square cos square theta. So this is the expression for y. Now this expression, you can of course 1 upon cos square theta. If you want, you can say sec square theta, right? But this is your this is your fourth expression. But now let's also do one more step. If we put, let's say this projectile is coming from here to here, that means when it reaches here, what is the vertical displacement? It's 0, because it has reached the same level, right? It has moved up and come down, so vertical displacement is 0. So if you put y is equal to 0, you should get x horizontal displacement as r. Okay, if you put y is equal to 0, because here the vertical displacement is 0, then the expression for x is nothing but the value of r, so it should match here. So let's do that. So what we do, we will put y is equal to 0 and rearrange these terms. So let's do this. Put y is equal to 0. So this is x tan theta minus gx square 2u square cos square theta. Okay, so I'll just take this thing on the left hand side, so which is gx square upon 2u square cos square theta is equal to x tan theta. So if you cancel x here, this is x is gone. On the left hand side, you'll get x equal to, we will transfer all these terms here. So you'll get tan theta. I'll write this tan theta as sine theta by cos theta into, you can take this up, so it is 2u square cos square theta upon g, right? This g comes down, so upon g. So what you will get here, you will see this, you will get a cos theta gets cancelled. So what you get here is 2u square sine theta cos theta, right? And you can see that it just will reduce to u square. 2 sine theta cos theta is sine 2 theta. So it is u square sine 2 theta by g. And if you see here, this is nothing but the expression for range. So x will be u square sine 2 theta by g if you put y is equal to 0. Thank you.